Okay, so good night, everyone. Today you're going to talk about the Jedi way to evolving software architectures, right? So I am Eduardo Guerra, but today I'm also here not only as a teacher from the university, I'm also part of the Saber Guild, the Trento Temple. We are a group that do cultural events on the characters of Star Wars. It's an official group recognized by Disney. And for example, I think two weeks ago we did the opening of an exhibition on Musi in Trento about science fiction. So we participate in a lot of these events, and yes, so today I'm also here as one member of this of the Saber Guild, and today I'm here as the Master Guerra Maedu, right? And I'm going to talk about the Jedi's path to software architecture that evolves, right? So maybe you know the Jedi path. I know you don't. And the Jedi path is there is no emotion, there is peace. There is no ignorance, there is knowledge. There is no passion, there is serenity. There is no chaos, there is harmony. There is no death, there is the force. So we are going to go through all of these steps of this Jedi path to see and talking about the issues we have with software architecture and how we can and what is the Jedi way we can solve it, right? So let's start with there is no emotion, there is peace, right? So yes, the agile method brought some peace to the galaxy, right? Before we have very bureaucratic processes that were kind of slow for changing to having, hello, uh, um, and yeah, it was a good thing, right? But a good thing is that the council don't need to know everything that the software needs to do right in the beginning of the project, so we can do it in small iterations, and in every iteration we can get feedback to know if what we are in the right path or not. So in a sense, the software needs to change and adapt on each of these cycles, right? So we have some code techniques that helped to make the code flexible enough for this change, like test-driven development, refactoring, clean code, domain-driven development or design, right? So all of these were techniques that helped the code to be kind of more flexible to be able to evolve, right? And the good thing is that the requirements were not all we needed in the beginning, right? So I like to say that developing software became a learning journey where you don't need to know everything in the beginning, but you learn through the process, right? So it's developing a software, it's a journey about maturity. So about knowing your institution and understanding it better as soon as the software is being developed, right? So, and that became a learning journey, not only for the developers, but also for the client, that when he has new versions of the software, he kind of every time understand better what he needs and can also mature inside him. Okay, but we have our master that said, dangerous designing software architecture is, right? So when we talk about evolving things, right, and changing things, when we talk about one functionality, it's one thing. When we talk about the architecture, that's something that can affect the whole software. Then we need to listen to Master Yoda, right? And of the project at the beginning, have all the information you need, you do not. right? So in a sense that in the beginning of the project, you will not know, for example, just as an example, how many simultaneous requests your software needs to handle, because that depends on so many factors that is hard to predict, right? So then you should not pretend that you know, because then it's dangerous, right? And then we have the final thought, that is high cost change in the architecture later can have, right? Which is when, like doing the agile approach, where we learn through this journey, right? And if we need, we change these techniques that works for the functionalities might not work well for the software architecture, because then changing the architecture can have a high cost, even if you have a good code, right? Maybe you need to change, I don't know, the access control model that you are using, and it's across all your applications. So changing it will have a high cost, right? Even if you are observing the good practices, right? So on one side, right, one day a Jedi meditating figured out that at one side, postpone decisions because we don't know enough. We have the risk of having dangerous consequences. On the other hand, making decisions earlier, we are going to base these decisions on uncertain factors. So what we can do, right? Maybe that's not a solution for that. And yes, the emotion can take us to the dark side, like something like, let's fix and deliver it fast, right? Nobody cares about quality. Nobody cares about code quality, right? Nobody will figure it out, right? You forget about the other person that needs to touch this code. The future you probably, right? You need to touch this thing and fix, and then you will feel what are the real consequences of this dark side, right? Okay, so then we go forward in the Jedi path to there is no ignorance, there is knowledge, right? But that part is kind of tricky, because then I will kind of pick up one sentence from a famous Brazilian song, right? That is, mas não sou mais tão criança a ponto de saber tudo, which translates to, but I'm not such a child anymore, to the point of knowing everything. Who knows everything? Who thinks knows everything? Are the children that don't have idea what does not know, right? So then we get the sentence from Confucius, that is, the real knowledge is to know the extent of one's ignorance. So in this part of the Jedi path, we talk about ignorance and knowledge. And the real knowledge is to understand the extent of our ignorance, to recognize the things we don't know, right? So do you think that you know everything you need to make all architectural decisions right in the beginning of the project? So you have kind of a project of this side. Do you think like right in the beginning you can know everything? And when we are writing software requirements, we normally write the things that we know we need to do in the software. And we think that that's all we need to develop this software. But I'm going to tell you that more important than the requirements and the things you know are the things you don't know. And usually the uncertainties you have in the project are the well-kept secrets that are told only on the dark corners of the galaxy, also known as the coffee room, right? So instead of sharing this with your team, there in the coffee room, you say, oh my God, I think this will not scale. or I'm not sure if this database will hold all the data we need. Right? So this is not said explicitly. This is only whispered in the corners of the galaxy. So then we have this thing like the known knowns, the unknown knowns, the unknown unknowns, and the known unknowns. So let's start with the easy ones, which is the known knowns. That are the things that you know, and you know that you know, right? So these are the, for example, when you know that your team have some capability and you know you can use, or you know you have some technology and you have control on how you can use it, right? This is the known know, so the team capability that you can use. And we have like the unknown knows, the things that you know, but you don't know that you know. So usually it's maybe a technology that you have there that you can use, but you don't know that it's available. Or maybe there's someone on your team that can do something that can be really useful in this project, but you are not aware of this capability, right? And then we have, let's go to the unknown knows, the things you don't know and you have no idea they exist, right? So these are like the things we are really hard to predict, that are unanticipated risk and opportunities, but the ones that we can do something about are the no one knows, the things that we know that we don't know, right? The things that we can recognize that we don't know. So then these are potential threats to the project that we can handle, right? And we can do something about all of them, like we can move the unknown knows with some research, some exploration. These unknown knows can be, for example, on the business side, can be on the technical side, and then we can do some research and exploration to make these questions, right? We recognize that something that we don't know. After all discovered started with a question, like, I don't know. When you recognize that something you don't know. And these unknown knowns, you can, with brainstorm and team collaboration, be more aware of the things you have available, and then you can bring them to here and make good use of them. And then when we have the no one knows, we can analyze, we can make hypotheses and test them. And this part is what we're going to talk here today, right? So make your uncertainties explicit, you must. So this is, if you can keep just one sentence from this presentation, keep this wise saying from Master Yoda, that you need to make your uncertainties explicit, right? And it's really rare who does that today, right? Because, as I said, they are only whispers in the corners of the coffee room. And we do that through hypotheses, right? So we put our team together and we start figuring out the things we don't know, and we put these things as hypotheses, right? And when we say this is a hypothesis, mean that we are not sure we can accept or reject that hypothesis, right? So we can have some technological uncertainty and we can have some uncertain requirements, right? So just giving examples. For example, this relational database will be enough to store the system data. That can be a hypothesis, but we are not sure of it, right? Or the application needs to answer to 1,000 simultaneous requests. This is a requirement, but maybe I'm not sure of it. Maybe it can be much more or much less, right? So when you say explicitly, okay, we have this statement, but this statement, it's not something I know for sure, it's a hypothesis, then your team will start thinking about, okay, but what can happen if we are wrong about this, right? So the uncertainties related to your architecture is an important knowledge to move forward. And as I said, sometimes knowing what you don't know, it's more important even than your requirements. Because usually, okay, I have this scalability, this security. Today we have a lot of solutions, right? If we are certain, we just go forward and implement it. But if we have uncertainties related, this is even more relevant than the requirements themselves, right? So we talked about the ignorance and the knowledge. So what knowledge is more important is actually the knowledge about what is our ignorance. And with that, we move forward to there is no passion, there is serenity, right? So passion might guide you to a path for immediate and fast solution, right? In Brazil, we usually say the fire. So we see some fire and we go there to deal with that. So you usually try to fix the things fast and immediate, and we are much more reactive to problems than trying to anticipate and deal with them, right? So that is the passion, when we kind of try to solve as fast as we can and we don't care about the future. We just want to solve these issues now. And with serenity, you can search for the knowledge to reduce the uncertainties. So if the uncertainty is the things we don't know, we can use this to search for the knowledge we need to reduce this uncertainty, right? So this way we can push the decisions to the future until we have more information, right? So, okay, I have to make these architectural decisions and I depend on things that are uncertain, that I put as hypotheses, right? And then I can try to find a way to know more, to get more knowledge, to be able to make decisions. So I can postpone to make that architectural decision until I know more, right? And then we have, there are many techniques I can, for doing this, and I pick up here just 3, and I brought some stories, right, about these 3, but there are much more. So the techniques I'm going to say, they are not complete, right? So what is an architectural spike? It's when you give someone for the team some time to study and explore something that can give more knowledge about technology or something that will help you, right? And this is not just saying for the developer, okay, study this, right? Because if you give me, how much time you give me to do that, I will do, because I love to new things. And because of that, you need to have a clear goal and a fixed time box. Like you are going to try to answer that question, and you are going to have that amount of time. If in that time you are not able to answer that question, you are going to share with us what you learn in that time, and then we are going to plan another architectural spike. So this way you don't lose a member of the team for a full iteration because he's just studying, right? So you can predict, okay, he's dedicated for this time. So we have this thing. That is a Jedi artifact called holocron. So these stories came from holocrons. I will leave it here. Okay. So this is the legend of the client who wanted direct database access, right? So this story, it's like that. We have a NoSQL database, and the application use kind of an adapter that make it looks like a relational database. And then there was one client that was very important that kind of have many units. And in the previous system, he have some functionality he did that he had direct access to the database. But in the previous software, each client has a dedicated database. And in the new version, we have the data from all the clients in the same database. So the issue was like how we can let him get access to the database, only having access to his data, and the fact that was no SQL and stuff, we didn't know kind of what this database supported. So then that was a big issue in the project, and we decided to do an architectural spike. And in the architectural spike, we say, okay, you have that amount of time, and we did some brainstorm and give to him like 4 options. So he spent that time. In the end of the iteration, he came and he said, okay, I did not finish, but I now know that these 2 first options don't work. And the third option might work, but it's not a good idea because of something he spotted, and said, maybe the 4th thing, if I can generate dynamically some script, maybe we can make it work. So give me more 2 hours to try it out in the next iteration. So he did that and it worked. He still needed to do some tweak to actually make it work, kind of generating some views dynamically, something like that. But in the end, we made it. And this is an example that he had like a very clear goal, and he have limited time each iteration, and then we go forward seeing what we learn in each one. So this is a way we can manage this. Trying to get more knowledge about something. We can also use software analytics, which is to try to get actionable information using data and metrics from software in the development process. And this is like, okay, I need to know more about this. Is there any metric or anything I can measure or collect that will help me to get more information about this? And about this, we have the tale of the handled exceptions, right? I remember that in a project, I was giving some consultancy, and then they called me and say, okay, we are having some errors are happening and they are not being showed to the client. And I said, okay, let's create a layer that captures the errors, something like that. And they said, no, you're not understanding. We have a lot of empty caches in the project, and it's not easy to kind of find. We have some variations like return catch and return null and other stuff. And okay, so I said, do you have Sonar Cube installed? And he said, yes, but when we turn it on, it throws so many warnings that we kind of was not good for having something red that the client can look for. And I said, okay, but let's take a look at it, not putting everything, because if you put everything, then it's just some numbers that has no meaning. So let's look at this and let's, for example, select only the rules about bad practices on exception and errors. So we looked in the rule database for exception, we analyzed each rule, then errors, and I think we activated kind of 9 rules. And then I remember it was like a microservices project, so it was not only one like code base, were a lot, kind of 9 or 10 code bases. But then when we executed these rules, we find kind of 4 or 5 violations on each project. And I say, okay, now fixing all of this is doable until the end of this iteration. So he said, okay, now that we have a clear guideline, so we get knowledge, we can do it. And then after they did it, I say, okay, now let's turn this into a rule that will not let people to commit code if they violate one of them. And actually they told me later that was a new intern that tried to commit a code. It's not working, I don't know why. And say, you have an empty cache, don't do that in production, right? So then, yeah, this was an example that we used not only the tool, but using the tool with a goal in our head to not get information, but get actionable information to use this in our favor. We also have the architectural trigger, which is where we monitor some quality attribute with a criteria related to when an action should be taken. Sometimes we say, okay, maybe it's too soon to actually do something, but we can monitor, for example, I don't know, maybe it's too soon to see if our database would be enough, but let's monitor the amount of data when we reach this, which is not when it's a problem, when it's almost a problem, we can start handling it. So you put kind of a trigger. Okay, I get this, now let's solve this problem. And this is from the Old Republic, which is the story of the notification performance in the age of the reverse Ajax. Anyone knows what is Ajax? Okay. Ah, you know, really? Okay. So it's not the cleaning thing, the cleaning product. It's asynchronous JavaScript and XML. So it's when the pages started to do requests that bring data and not the page itself, right? So I remember this was starting, and we have a project that needs reverse Ajax. It was an emergency system like this. Here is 112, right? So the thing, like, you have someone that answers the call, and then there are some people that are dispatchers, like for the ambulances, for the police, for the firemen, and then this person kind of register and select who. There are others. I remember there was like 6 different ones, and it has like a web page. So when it click and submit, it should appear on the other screen, so they can, for example, okay, someone was get a shot, so maybe lightsaber was stolen, so maybe activate both the police and maybe a hospital if someone is hurt. So then it should appear, and there was like, of course, as you can imagine, we cannot wait so much time, right, in these domains. So we have time requirements. I think like was 2 seconds that the other person needs to receive the notification. And we were using some kind of reverse Ajax libraries that open source and was not maintained, so sometimes we were kind of afraid of using it. But let's say, okay, instead of trying to do, let's use it and let's put an architectural trigger. So we put some measurements that kind of register the time when the notification was triggered and when it was received, and we start monitoring this and say, okay, if it gets like 1.5 seconds, then we start worrying. And the good thing is that we never have to do anything about it, because this trigger never trick. But it's completely different to not having a problem and not being prepared to handle if there is a problem. If something happening, we are going to know in time to deal with that. Okay, so the journey towards gathering knowledge is about the hypothesis reduce the uncertainty. So this is a way, these are, I said I'm going to talk about 3 techniques. There are others that you can use for reducing the uncertainty. So when you identify a hypothesis that is an uncertainty in your project, you can use one of these techniques to reduce this uncertainty. And there are some hypotheses. Usually, for example, you have a hypothesis that is related to the lack of knowledge of your team. Maybe they don't know how to deal with some technology. Then maybe this is something that can be solved. But sometimes you have something that is related to performance, that might, some things in the environment or a new piece of code might change. So maybe that uncertainty will remain until the end of the project, and it's something that you need to monitor and keep your look at it. So the fact is not try to solve all uncertainties, but try to reduce them, and some of them you need to keep being monitored. Okay, so then let's go to there is no chaos, there is harmony, the next step of our Jedi path. So just pushing the decisions to the future can lead to chaos, right? So as I said in the beginning, it's not so easy to say, I don't know what I need to know to make this architectural decision, so let's just not make this decision right now. And then later, you have to make a change that can be huge, right? So let's remember what Master Yoda said. High cost change in the architecture later can have, right? So like just postponing the decisions and searching for reducing the uncertainty is not enough. We need to handle with the potential impacts that this uncertainty can have. When we say, okay, I'm going to make this decision in the future because I don't know enough, I have to say, how can I reduce the impact of making this decision in the future? And like I did before, I'm going to, I pick up 3 techniques, not the only ones, with stories, right, that talk about techniques we can use for reducing the impact. Okay, the protective guideline, you need to use that Jedi trick, right, to make your developers don't do something dumb, right? So you kind of create a guideline and say, all the team will follow that code practice to reduce the impact of making that decision in the future. Like, for example, maybe you don't know if you are going to go for option A or B. You don't make the decision. Of course, if you choose to use a library that is not compatible with one of them, you are already making the decision. Or you are creating a high impact if you need to go to the other side, right? So like that could be a guideline. So sometimes it's something that is simple, but it's only simple if you think before. If you let them use it and try to change it later, would be nothing simple, no simple, chaos, right? So let's go to the story. It's the chronicle of the components that might become remote, right? So we had some, this story, it's about, I don't know how to say in English. It was this system, like sales systems from stores, right? So it was a system that works was for big stores, and it had a local database. So each system kind of have a local database, but they are selling this for kind of these a very small stores that was not viable to have like a database for each one. So then the idea is to be possible to have part of the system remote. So kind of pick up, it was like a desktop altogether, kind of the classic client server. So we wanted to put like another layer of networking and have making a lot of stuff. So this was not certain. This was kind of, we didn't know if we are going to need to do that in that system or not. So then we define this guideline, because one of the things that make hard to distribute the components, of course, is to have, for example, some place that you share data there. Like, okay, in the most, let's say, raw case, like a static variable. But yes, we have other stuff that are not static variables that you have, I don't know, a kind of a shared list that every component can go there and take that list and get information from there. Like decentralized places, we can get information. This kind of thing makes really hard to distribute, because then if you have them in the same place sharing that data, if they are now in different machines, they are going to interact with there, and they will not synchronize with the other side, right? So then we created that guideline, and the fact is that actually and we have to refactor some things that we already have that use that, but then we start not using that anymore. So then when we migrate to, when we have actually, that actually was kind of like this, then the company kind of fallback. So, okay, we're not having to need to have these anymore. Then kind of 2 weeks later, oh, surprise, we closed the deal. So yeah. So then the fact that we are doing this make a lot of easy to migrate to this new architecture, right? Because we avoided some impact. Of course, it was a lot of work, but at least was more like on the interface and stuff, and not in the functionality itself. Modularity is something we can use for isolating part of the system that might be affected by changes, right? So, for instance, we have a part of the system that might change in the future, that will be affected by that decision. We can try to isolate most as possible from the rest of the software. So if we need to change it in the future, that change it will be kind of isolated. Right? And for that, I have the ballad of the unstable integration with external systems, right? So we have this software was from, it was like a company that kind of handle like medical plans, and you need to integrate with a lot of laboratories and pharmacies and systems that the doctors use. So there are a lot of systems, some of them kind of from big companies, but some kind of developed internally. So these systems were kind of really unstable. Some of them kind of receive like changes in the APIs. So sometimes they just change something and then the whole thing stopped working because they are getting an error there. So, and then facing that uncertainty, we decided to, okay, all integration with the external systems will be isolated, and we even make it asynchronous to not be part of the application main flow. So we don't like stop a functionality because of that. And then every time we have some piece that need to be changed that was really isolated, and we could handle that without affecting the rest of the software. So this is a case of how the modularity help us to deal with this uncertainty on the changes and the maintenance for dealing with these changes in these external systems. And finally, some flexible solutions, right? To use a solution that allows the system to be easily changed in the future. That is not only modularity, it's not only the guidelines that can help with that. Sometimes you can have some techniques. For example, I can choose, if I'm not sure about the kind of rules that I need to handle in my access control model, maybe I can choose a model that allows a higher number of possibilities, even if it's more complex, gives me more flexibility. So I'm kind of compensating this. Like I can, let's go to our story, maybe it's going to be clear, right? So the fable of the uncertain scalability of the system features, right? So there was this system that from a startup, and it didn't know, for example, if the business model they are going to sell for other companies. In this case, let's say the number of clients they might have are not so large, because then they will kind of sell for the final clients, and or if it's going to sell directly to the end clients, and then they will need to scale a lot, and they have no idea on how much customers they might have. Going to the final customers, they didn't have a dimension. So facing this uncertainty, they didn't want to make a decision right now, but they decided to go for a flexible solution for scalability, which is, for example, going to an elastic cloud solution, right? And maybe they will not actually need it if maybe they go, but then they protected themselves from the possibility of needing going for a solution that allows them to scale or not. Okay, so and then we can also use our creativity. That's depending on the kind of uncertainty we are facing, how we can protect ourselves from this impact. And I see things really amazing, kind of out of the box, that can really work for that specific system, right? So and then that can protect from the danger of the uncertainty. So if at one point we try to get more knowledge to reduce the uncertainty, on the other side we also adopt some techniques for protecting us from the impact of postponing that decision. And finally, the last point of the Jedi path is there is no death, there is the Force, right? So the wrong architectural decisions made at the wrong moment can be fatal to the project. And sometimes that's only not just one death, but that death can have other worse consequences for the company and maybe even for the galaxy, right? So as we see in this example. And then the Jedi used the Force to develop this technique based on these principles, and we call this technique arc-hypo, and arc from architecture and hypo, not from the hippopotamus, but for hypothesis, right? So, and then we have here, right, some of the patterns of the practices we documented for this. Some of them that I already told you, but you see pattern for using hypothesis engineering to manage architectural uncertainties. The other one is about making small adjustments on the development project that can help you to manage this. This one is to evolve architecture. And also we have some results also from case studies. One of them actually from Catch and Solve, this one from IEEE software. The other one is still not accepted, but almost, and was in a large company from Brazil that have to develop in 3 months a new system that actually is the system that distributes the money on the state of São Paulo. And the fact is that if they don't finish and work in 3 months, I don't know, hospitals, they will just not receive the money from the budget. So it was really a challenge, and they used these uncertainties and they were able to kind of anticipate the issues and handle them in time, and actually not all of the same time, but they kind of consider how much uncertainty. In some cases, they protect themselves with the impact to be able to make that decision later in the project. So they were able to deliver and kind of anticipate all of this. And it's reported in detail in this paper, right? So then, what is this? So getting fast on how this arc-hypo works. It's kind of what I told you here, like identify the uncertainties and document as hypotheses. Evaluate each hypothesis, how much it's uncertain, how large is the impact. And then for each hypothesis, create a technical plan considering the impact and the uncertainty. So how we deal with the uncertainty, how we deal with the impact. And even doing nothing can be a decision. But then I always say that making a decision, like deciding for doing nothing, is different for doing nothing because you ignore the problem. Then you are going to include the actions of this technical plan in the project iteration. So now that will become tasks that you are going to plan, right? Together with the functionalities. And then in the end of each iteration, you are going to evaluate what you did in that iteration and how that changed the hypothesis. So this hypothesis now is solved, has a lower uncertainty. Maybe sometimes we find out things that, okay, this is worse than I thought, so maybe it can go high. But now you know the problem is big. It's better than not knowing, right? And yeah, so then you re-evaluate the hypothesis. And new hypotheses might also appear when you have maybe a new business opportunity or something change on the market, or you have a new technology to be adopted, right? So you might have new hypotheses also coming in. And then what is an architecture that evolves, right? The decisions are made at suitable moments. The architectural work is divided through the iterations. It's not done everything in the beginning, pretending that you know everything. So you can plan and divide the architectural work through the iterations. And be prepared for changes that are brought by the uncertainties. So maybe you are not going to remove completely the impact, but you can reduce it a lot. And if you get this, you do not rely on what is uncertain for the decision, and you also don't ignore the impact of the decisions that you choose to postpone, right? And as I said, if you can keep just one sentence for this presentation, it is this one: make your uncertainties explicit, you must. A wise quote from our Master Yoda. That's it. Thank you very much.